Hello, this is the lecture number 1 for the chapter Mathematical Induction for the class 11th. Now in this, first of all, we'll discuss the principle of mathematical induction. Now what this means. Let Pn be the statement involving the natural numbers. This is the main thing, that is the natural number. Then if P1 is true, P1 is true means when this statement is true for first natural number 1. Then Pm plus 1 is true whenever Pm is true for all the natural number n. That is, whenever the statement is true for any natural number m, then Pm plus 1 must be true for all natural number n, where m or m plus 1 is also a natural number. We conclude that the Pn is true for all natural number. Then we can say that that statement is true for all natural number. That it means that first of all we will prove that it is true for first natural number, that is 1. Then we will prove that it is true for m plus 1, which is a natural number, whenever Pm is true for all natural number n. So this is the principle of mathematical induction, or in other words, to prove that the statement Pn is true for all the natural number, then we have to go through the following steps. That is, first of all, we verify that the result is true for the n is equal to 1. That is, it is true for n is equal to 1, first natural number. We assume that the statement is true for the positive integer n is equal to m, that it is true for n is equal to m, any natural number m. And we'll prove that the result is true for n is equal to m plus 1. First of all, we'll prove that it is true for n is equal to 1. Then we let that it is true for any natural number m. Then we prove that the result is true for n is equal to m plus 1. Then we can say that the statement is true for all natural number. Now in this chapter we have only one exercise, that is the 4.1, and almost all the questions we have to do the same way, and we are starting with the question number 1. Now it is given that the sum of this series 1 plus 3 square up to 3 raised to power n minus 1 is equal to 3 raised to power n minus 1 upon 2. Now you have to prove that it is true for all natural number n. So what you have to do, first of all, you have to let the statement be Pn. Now, according to the principle of mathematical induction, we will prove that this statement is true for n is equal to 1. And we then let that it is true for any natural number m, and then we'll prove that it is true for any the exactly next natural number, that is m plus 1. Now, first of all, we let this statement as Pn, and it is equal to 3 raised to power n minus 1. It means that the sum of one term, if we replace n by 1, we'll get the sum of one term. If we have to obtain the sum of two terms, it means when we replace n by 2, the sum of two terms will obtain by this statement, and so on. That it is true for n is equal to any natural number. Now, for n is equal to 1, it means that the sum of one term, in the left hand side is 1. Now, the sum of this series is equal to this, so it must be true for this. So we prove that that it is true for n is equal to 1. To replace n by 1 in the right hand side, you are getting 3 raised to power 1 minus 1 upon 2, which is equal to 1. The left hand side is equal to the right hand side. It means this formula or the statement is true for the one natural number, that is the sum of one term in the left hand side is 1, and it is coming out to be 1 in the right hand side also. It means this formula is true for, or a statement is true for n is equal to 1. Now, we let that Pn is true for any natural number m. Any natural number n, so you have to replace n by m. That it means that the sum of m natural number will be equal to 3 raised to power m minus 1 upon 2. So we let that this statement is true for n is equal to m. So 1 plus 3 square up to 3 raised to power m minus 1 is equal to 3 raised to power m minus 1 upon 2. Simply replace n by m. When it is formula is true for n is equal to m, then replace n by m. Now we have to prove that this statement is true for exactly next natural number, that is m plus 1. So you should obtain in the right hand side 3 raised to power m minus 3 raised to power m plus 1 minus 1 upon 2 in the right hand side for when we will prove that it is true for the next natural number m plus 1. So how you have to do it? Listen it very carefully. You simply you have to add the next term of this term to the both the sides, because we have to find the sum of m plus 1. This is the sum of m and you have to find the sum of m plus 1. So means next number we need. So now what is the next number of this? You have to replace m by m plus 1. So replace m by m plus 1 here. So it means you have to add the next term of this term to the both sides. So replace adding 3 raised to power m plus 1 minus 1 on both sides. This, add this and to the right hand side. Now you have to do nothing in the left hand side because from 1 to m plus 1 term is here. Now you have to prove that it is true for m plus 1. So by solving this, you must obtain 3 raised to power m plus 1 minus 1 upon 2 in the right hand side. So you have to simplify on the right, only the right hand side. Now simplify it. 3 raised to power m plus 1 minus 1 means 3 raised to power m. You add these two terms simply, and what you are seeing that 3 raised to power m and 3 raised to power m, these are the two like terms. So you can add these two, or you can take 3 raised to power m common in these two terms. Take 3 raised to power n common in these two terms. So it will be 1 plus 2 and minus 1 as it is. I am taking 3 raised to power m common in these two terms. So 1 plus 2 and minus 1 as it is. It is 3. 3 means 3 raised to power 1. When you multiply having the same base, the power will be added. So it will be m plus 1. M plus 1 minus 1 upon 2, which is the sum of m plus 1 terms. Because when the sum of m term is 3 raised to power m minus 1 upon 2, the sum for n is equal to m plus 1 should be 3 raised to power m plus 1 minus 1 upon 2, which we have obtained. So it means it is true for n is equal to m plus 1. So what you have to write in the end? That Pm plus 1 is true whenever Pm is true. This statement you have to write. This is the principle of mathematical induction. So Pm plus 1 is true whenever Pm is true. So therefore by principle of mathematical induction, Pn is true for all natural number. The Pn is this statement. Pn is this statement, that this formula or the statement is true for all natural number. So first of all, we have proved that it is true for n is equal to 1. Then we have let that it is true for any natural number m. Then we have proved that it is true for n is equal to m plus 1, and by simplifying the right hand side. There are two types of question in this chapter. First is this statement, and second type in the end of this exercise. We will discuss it later. Now similarly is the question number 2. The sum of this statement, that is 1 cube plus 2 cube plus 3 cube up to n cube is equal to n plus 1 upon 2 whole square. Now you have to prove that it is true for all natural number. So let again the same way, let this is equal to Pn. Now for n is equal to 1, the sum of one term in the left hand side, it is 1 cube, that is 1. In the right hand side, replace n by 1 to 1, 1 plus 1 upon 2 whole square, it is coming out to be 1 also. Left hand side is equal to right hand side. It means that this statement is true for n is equal to 1. So P1 is true. Again in the same way, you let that it is true for any natural number m. So simply you have to replace n by m here, m in the left hand side as well as in the right hand side, and you have to prove that it is true for n is equal to m plus 1. Simply as we have done in the last question, you have to add the next term of the left hand side to both the side. So this is the last term of this left hand side of the this Pm, m cube. The next term will be m plus 1 whole cube. The next term of this will be m plus 1 whole cube. So adding m plus 1 whole cube on both sides. This in the left hand side, this and m plus 1 whole cube to the right hand side. Nothing you have to do in the left hand side in all the questions. Simply you have to simplify the right hand side and you have to obtain the next term of this, or in place of m you should you should obtain m plus 1. So you should obtain m plus 1 m plus 2 upon 2 whole square for the natural number m plus 1. So I am simplifying the right hand side. So it is simplify it. I am getting m plus 1 whole square common in these two terms. M plus whole square common in these two terms. So you are getting m square upon it is 2 or m plus 1. Add these two terms, add these two, and this will be the whole square of m plus 2. M square plus 2m plus 2 will be the whole square of m plus, it will be 4 here. This is 2 square, that is 4. If you added m square plus 4m plus 4, which will be the square of m plus 2, and the 2 as it is. 2 as it is. So it is comes out to be m plus 1, m plus 2 upon 2 whole square, which is the sum of m plus 1. M plus 1, m plus 2 upon 2 whole square we have obtained in the right hand side of this. So this is the method as usual in the last you have to prove that therefore Pm plus 1 is true whenever Pm is true, therefore by PMI Pn is true for all natural number. You have to write these two statements in all the questions. So do these two questions very carefully, and almost all the questions you have to done like this. Starting you should be fixed, and the end of this all the questions is also fixed. We'll discuss the remaining questions in the next lecture. Thank you.